Welcome to lesson 3 about maps and dynamic memory allocation. Okay, maps are pretty simple. The type signature for a map is the keyword map followed by the key type, which is in square brackets, in this case a string key, and then the value type, which in this case is an integer. And after that you have the actual values. So here we have the key, which is a string, Bob, and the colon maps onto integer, which is 24 in this case. And these key value pairs are separated by a comma. I think that's pretty straightforward. Here's how you reference them. Here's how you iterate over all the key value pairs in a map, and that's through the range keywords. Pretty useful. Dynamic memory allocation. Well, let's look at this little statement here. This is how you dynamically allocate one thing. We've got a literal here, and we're taking an address and we're assigning it to a variable. So we'll get a pointer. In this case, dynamic person is a pointer. Now, when this pointer goes out of scope, then this object is going to be garbage collected. But if I happen to assign, if I can keep this piece of memory alive, from one, even after I leave a function or leave the current scope, if I return a pointer to it, or I make some data structure point to it, or whatever. So really there's nothing to dynamically allocating one individual object. But what we have, there is a rather fancy system for dealing with dynamic arrays, and this is where you want an array that is going to be resizable. And we use this function called make to create a dynamically resizable array, and it's a bit of a clever trick really, because what happens is this function returns a slice. You remember a slice is a window onto an array. It is a position and a length, what happens here is that we want a capacity of 3, and we want the array, our slice, to be to start off being 0, a size 0. So what happens is an array gets allocated in memory of size 3, then a slice is created which is looking at that array, but only the beginning of the array, and it's set to length 0, and that slice is returned into this variable here, right? So now we have a slice which is size 0, but it's looking at an array which has capacity which is size 3. So then we can use this append function to append new person objects onto the end of the slice. And what that's going to do is it's going to stick them in the underlying array and then make the slice window 1 bigger, so the slice will be able to see the new thing that's gone into the underlying array. And what this append function returns is a new slice, which or is the same slice modified so that it can see the new item that's been appended. And so it gets bigger and bigger and bigger as you add new items. And here we're adding 3 items. So now the underlying array that we allocated up here with capacity 3 is now full. And so what's going to happen when we append something else? So here we are appending something else. And what's going to happen here is a forced reallocation. So we started off with an array size 3 and a slice looking at it on the top. And now we've filled it up, and now we're going to have to get rid of that array of size 3, and we're going to have to create a new array size 5 and copy the old one into it, and then return a slice that's looking at that new array that we've allocated. So there's a reallocation forced here, and this slice that gets returned is going to be looking at a different array from what it was before. And that's why we've got a little bit of code here which we've saved the original slice. And if you, at this point, you've got 2 slices that are looking at the same underlying array, and suddenly here you've got a different slice that is returned by after this append operation, because it's now looking at a different underlying array, and there's some code here to sort of demonstrate that that is all happening. And just for fun, let's run all this stuff. So we're seeing things being appended, and we're seeing that in the end our two slices, although they started off being the same thing, after the forced reallocation they're not the same thing anymore. So that is a thing that's fairly interesting bit about slices. And you can also make maps. Here you can see that the first parameter to this is a map type, with showing the map type signature that we want to create, and the first option to this is the capacity for it. And here we are assigning. So this is just for efficiency. So your map starts off being roughly as big as you expect it to need to be, so that you don't have to keep reallocating it. Anyway, I hope you enjoyed that, and we'll see you in lesson 4.